This time we're given some more information. We're told that PT is 20, QS is 6, and PQ, QR, and RS are all equal. It says find the length, or find each length. Now, a lot of times what I like to do is I like to make notations up here. So we're told first that PT is 20. So that tells me my whole length up here is 20. What else are we told?
QS is 6.
6. And then we're also told what? Yeah. How do we represent that? Yeah, we do a little tick mark, right? These are all okay. Now, if you're ever relying on my diagrams, they're never drawn to scale. So if things look like they're equal, don't assume they are. If things are equal but they don't look like it, again, don't assume that. Don't trust my drawings, they're never drawn to scale. Okay, so let's look at number 5. What do we ask to find? QR. Okay, so what can you guys tell me here? What do we know that would allow us to find the length of QR?
It's half of QS.
Okay, it's half of QS. Another way we would write that is the fact that QR plus RS is equal to QS, right? You guys agree?
Yeah.
Okay. Now how long is QS?
6.
Yeah, that's 6. And up here we're told that QR is equal to RS. So it's really as if I had 2 QRs. So how would I solve for just QR? Divide by 2. Therefore QR is, hey, was that bad? That was horrible. Yeah. Barely survive it. Alright, let's look at number 7. What are we trying to find the length of? SP. Okay, so what is SP? SP is PQ plus QR plus RS. Okay, the good news is we've already done half the work for this. Because we all know that all 3 of these are equal. And up here, number 5, how long was QR? 3. So what's 3 plus 3 plus 3?
10.
How about 9? Alright guys, any question on this? I don't think we need to spend any more time on this page. You guys kind of get the idea? Alright, let's make it a little more complex. Okay, you guys will see questions like this on the assessment for this unit. It's really not that hard here. Okay, number 9. Gotta find the length of AC. So what do? Yeah, just add them up, right? Sum of the parts equals the whole. And again, guys, if we go back to our geometric equation, AB plus BC equals AC. Right? That's our geometric equation. Sum of the parts equals the whole. All you have to do now is substitute. How long is AB? 2.8. How long is BC? So then how long is AC? Good job, Brandon, listen up. All right, we're looking at number 10. We're going to set it up exactly the same way. The sum of the parts equals the whole. So we have LM as one part, MN as the other, and that's equal to the whole segment, which is LN. Okay, what are we solving for? LN, so that's going to be our variable. We're going to leave that alone. We don't know how long that is. How long is MN? 2.8. How long is LN? Okay, what do I have to do to solve for LN? Subtract. You got 1.2. And should probably keep our units on there. I know my science teacher friends would be very upset with me, and the fact that I teach science. I always forget to keep on the units, but that's the math teacher in me. All right. Oh, again, guys, here's another perfect example. If you look at M, M looks like it's perfectly in the middle. But if you do the math, clearly it's not. Okay, don't trust my diagram. All right, next page. I want you guys to take a few minutes. I want you to do these. Don't be freaked out because there's fractions. Deal with it. Okay, I want you guys to solve for number 11 and 12. Okay, so let's take a look at this word that our fellow students did here. So we look at number 11. We have DE plus EF equals DF, which is good. All I gotta do is substitute the 2 3/4 for EF. And all I gotta do is subtract it. Now, this is the point where I want to make sure that we had this discussion. I know a lot of you guys are not great with fractions, and you freak out. There's a lot of different ways you could handle this problem. There's a way that I do it mentally, and then there's a way that I can do it algebraically. I'm going to show you both ways. When I look at this problem right now, and the fact that that's a whole number, the 12 is a whole number, it's actually not that bad. Because if I got to subtract 2 3/4, I'm going to do this in 2 stages. First, I'm going to subtract 2, and then I'm going to subtract 3/4. So what's 12 minus 2? 10. So now I'm at 10 wholes. And now all I have to do is subtract another 3/4. So where does that put me in? Somewhere between 9 and 10, right? Well, if I'm subtracting 3/4, how much is left over? 1/4. So 9 1/4. Okay, so there's one way to handle that. The other way is to actually go in and do this with a whole lot of math, which is still not that bad. Let's treat that as 12 over 1 minus 2 3/4. And the way I'm going to handle this, I'm going to treat this fraction here that's mixed, I'm going to turn it into improper. You remember how to do that?
Yep.
Okay, how do we do that?
Don't you got like, what is this? Plus 1
You multiply this direction, and then we
plus
add the top. So 4 times 2 is 8, plus 3 is, so there's 12 minus 11 fourths. So what do I need to do now? Get a common denominator. So that gives me 48 twelfths. Oh, got that. Screwed that up already. Well, 48 fourths minus 11 fourths, and that gives me 37 fourths. And a lot of times, I'm okay with that as my answer. Here's the thing, we're talking about this on, I think, the second or third day of class. A lot of times in math, 37 fourths is completely fine. But if you're working in any type of like design or engineering, 37 fourths is not okay. Because no one has a clue what 37 fourths, really try to picture 37 fourths. Does it make any sense to you? No. But 9 1/4 does, right? Most people can envision 9 holes in another quarter. So that makes sense, but 37 fourths makes no sense. But they are the same thing. So a lot of times in math class, we get numbers like this, but then the real world starts yelling and saying, no, we need that differently. Either we need it as a mixed, or we need it as a decimal.
So you pretty much taught us to reduce.
Reducer, no, reduce.
So you have to.
That, okay, 37 fourths is reduced. Now, if I'm telling you to put it in mixed form, then do that. If I'm telling you to write it as a decimal, then do that. What I want you to be able to do is go between the 3 without any issue. All right, we look at number 12. I like if you look at number 12, and think about it logically. I like the fact that the person found a common denominator. We have 5/8 here. We have a half here. So they multiply by 4. So that gives me 2 4/8. Now if you add your wholes, we got 4 plus 2, which is 6. Well, what's 5/8 plus 4/8?
9/8.
9/8, which is actually 1 and 1/8. And if we add that to the 6, we're at 7 and 1/8. It's a lot of fractions. Not so scary. All right. Here's what the majority of your homework is going to look like.
Yes.
Read the directions.
T is between S and U.
Okay, take a few seconds. Draw that out. Draw that picture. T is between S and U. I want every single person right now to draw a model of that statement. T is between S and U.